everybody, happy Thursday. We're going to go through our next lesson in Unit 8. We're still going to be talking about using proportionality theorems. So the first theorem that we're going to be taking a look at today is the two-transversal proportionality theorem. And it says if we have three or more parallel lines that intersect two transversals, then they divide the transversals proportionally. So if these three lines going across horizontally are parallel to one another, they are intersecting the transversals, these two lines that are running up and down. And they are splitting those transversals into parts that are proportional to one another. So on the first transversal, the three lines are creating two parts here and here. And then the three lines on the second transversal are creating two parts in the same position here and here. So those two parts are going to be proportional to one another. So the first part on the first transversal is AB, and I'm going to compare that to the second part of that transversal, which is BC. And that ratio should be equal to a ratio comparing the two parts on the second transversal. Another thing I want to point out here is that we might have more than three parallel lines. So we might have more than just these two parts in between the three parallel lines. In a couple of examples that we're going to see in a few minutes here, it might also be helpful for us to compare smaller parts to larger parts. So for example, like this proportion would hold true based on these three parallel lines cutting these two transversals. Another proportion that might be helpful in a particular problem is, let's say we're going to create a ratio with the first part, AB, but for some reason we want to use a larger part. So I could compare AB to this entire piece here, AC. And that ratio would be equal to this first small part on the second transversal, DE, and AC, this entire section, corresponds to DF, this entire section. So again, that might be helpful in a couple problems that we see in the homework or we see in the video for today. So for the first example, it says find the value of x, and I have three parallel lines intersecting two transversals. And I see that the three parallel lines are creating two different parts on each of those transversals. So I'm going to set up a proportion comparing on the first transversal the two parts. So 3x and 5x, and then the corresponding parts on the second transversal. So 60 and 8x. I'm going to go ahead and cross multiply to solve. 3x times 8x would give me 24x squared. 60 times 5x would give me 300x for the other cross product. Now, how I'm going to go about solving this is I'm going to go about solving this by factoring, because I have an x squared term, I have an x term. So I'm going to bring the 300x over to the other side. So when we solve by factoring, we always want to get 0 on one side of the equation. Now, over here, we have a GCF. There are common factors between 24x squared and 300x. And the greatest common factor between the coefficients, 24 and 300, is going to be 12. The greatest variable factor between the x squared and the x is x. Each of those terms has an x in common. So I'm going to factor out 12x which is the same as dividing out the GCF from both of these terms. And if I do that inside the parentheses, I'm going to get 2x minus 25. When we solve by factoring, we set each factor, each term, each quantity that we're multiplying together equal to 0. Now, if I solve for x here, I just have to divide by 12. 0 divided by 12 is just 0. Now, x can't actually be 0 in terms of the context of this geometry problem, because if it were 0, this would have a length of 0, this would have a length of 0. So we wouldn't actually have any distance between these parallel lines. So the diagram kind of ends up falling apart. So x can't be 0. If I solve here, if I add 25 to both sides and then divide by 2, I'm going to get x is equal to 25 halves or 12.5, which it can be 12.5. That's a positive number. We would have positive segment lengths there. So for the next example, it says find the values of x and y. And again, we are given parallel lines. This time we have 4 parallel lines intersecting the 2 transversals. So in this example, I see the parallel lines creating 3 different parts of the 2 transversals. So I'm going to first work with the first 2 parts. So I'm going to set up a ratio comparing part 1 and part 2 on the first transversal, and I'm going to set that equal to a ratio comparing parts 1 and 2 on the second transversal. Now I'm going to go ahead and cross multiply. And if I divide by 7, I'm just going to leave my final answer as a fraction because it ends up not being a super nice decimal here. So I'm just going to leave my answer as y equals 24/7. Now, I found the value of y, but I also need to find the value of x. So what I'm going to do now is set up a second proportion. And what I'm going to decide to do is now create a ratio on the first transversal comparing part 2 to part 3. So 7/4 comes from the first transversal. Now I'm comparing though parts 2 and 3. And I'm going to set that equal to a ratio that compares parts 2 and 3 of the second transversal. So that's going to be 8 and x. Again, I'm going to go ahead and cross multiply. And I'm going to divide by 7. Again, I don't get a lovely decimal, so I'm just going to leave my answer as an improper fraction, so 32/7. So again, one more example here. We have 4 parallel lines. So I have the little arrow marks saying that I have 4 parallel lines. They're intersecting 2 transversals here. So they're splitting the transversals into 3 small sections. What I'm really interested in this problem is finding the length of HG. So I'm going to put a little X here. I'm going to let HG, sorry, my dogs. I'm going to let HG be X because that's what I want to find. The other thing that I'm given here, the other piece of information I'm given here is that HE is equal to 24. So let's look at where HE is. It's from here to here. This has a length of 24. And this 24 spans parts 1, 2, and 3. If we added parts 1, 2, and 3 together on transversal number 2, we would get 24. So when I go to create my proportion using this theorem, I definitely want to use part 1 of the 2 transversals because that's where my X is and that's what I want to find. So on transversal 1, I'm gonna start in the ratio by putting a 5 up top. Now, because I don't know any of these smaller parts, 2 and 3, on transversal 2, I am gonna have to use 24, which is parts 1, 2, and 3 combined. So I wanna make sure that I now, over here on transversal 1, combine parts 1, 2, and 3. So if I add 8 and 2, that gives me 10 plus 5 is gonna be 15. So I'm gonna compare 5 to 15. This was part 1, and then 15 came from adding parts 1, 2, and 3 on the first transversal. And I'm gonna then fill in the second ratio with those corresponding parts on transversal number 2. So part 1 is X, and then parts 1, 2, and 3 combined are 24. I'm gonna simplify 5 over 15, and I can take out a common factor of 5, and then I get 1/3 equals X over 24. I can use cross multiplication or equivalent fractions here to find X. I know that to get from 3 to 24, I have to multiply by 8. So if I do the same up top, 1 times 8 over here in X's position would get me 8. So X is going to be 8 for this next example. All right, so the last theorem, the last proportionality theorem we're gonna be talking about is triangle angle bisector theorem. And it says if a ray bisects an angle in a triangle, it divides the opposite side into segments that are proportional to the 2 adjacent sides. So in the diagram, we have an angle bisector. AC, ray AC, bisects angle BAD. And I know that because of the arc marks here. And when I have this ray bisecting the angle, it is splitting this third side, this opposite side of the angle, into 2 parts. So those 2 parts are going to be proportional with the 2 adjacent sides of the triangle. So my first ratio, I'm going to set up a ratio that compares the 2 parts of the third side of the triangle. So BC is one part, CD is the other part. This ratio is going to be proportional to the adjacent sides of the triangle. So up top, BC, this segment here, is adjacent to side AB of the triangle. So again, these are adjacent. BC is adjacent or right next to side AB of the triangle. CD down here, the second part of the third side of the triangle, is adjacent to side AD. So again, these 2 sides, or this piece and this side, are adjacent in the triangle. So when I compare the 2 sides of the third side, the 2 pieces of the third side of the triangle to their corresponding adjacent sides, those ratios should be the same thing. They should be proportional. So we're going to be using triangle angle bisector theorem for the remaining problems today. So in the next one, it says find RV and VT. So SV is an angle bisector because I have the 2 arc marks here. So it is splitting this third side into 2 parts. So when I go ahead and make my proportion, my first ratio is going to be comparing these 2 parts of the third side of the triangle. Now, to figure out what ratio I'm going to set this equal to, I put X plus 2 up top. So X plus 2 is this segment here. So I want to find the adjacent side of the triangle to segment RV, which is SR here, which is 10. Then in the bottom, I have 2x plus 1, which is adjacent to the side length of 14 in the triangle. I'm going to reduce 10 over 14. Both of them are even, so I can take out a 2. I'm going to go ahead and cross multiply. So I'm going to have to multiply 5 by the quantity, 2x plus 1. And I'm going to have to multiply 7 by the quantity, x plus 2. So I have to distribute. If I go ahead and subtract 7x from both sides, over here I'll get 3x. If I subtract 5 from both sides, I'll get 9. If I divide by 3, x has to be 3. So I want to find RV and VT's length. So if x is equal to 3, 3 plus 2 is going to give me 5 for the length of RV. I next have to find VT. So if x is 3, 3 times 2 is 6, plus 1, VT would be 7. So the second example here says find the value of x. And again, I have an angle bisector. This segment here is an angle bisector because I have 2 arc marks with a tick mark on them, so signifying these 2 angles are equal. So this segment is splitting the third side into 2 parts. It's not bisecting it, it's just splitting that third side into 2 parts. So part 1 and part 2. So when I go ahead and make the proportion, the first ratio I want to create is a ratio comparing these 2 parts of the third side of the triangle. The problem is I actually do not have a length for the first part. I know that the second part is x, and I know this entire third side is 10, but I don't have any expression or number for part number 1. Well, if I know this whole entire third side is 10 and a part is x, this section would be 10 minus x. The whole segment minus the part we know would give us the remaining part. So 10 minus x would be the part 1 of that third side of the triangle. 10 minus x is adjacent to the side length 15 in the triangle, and x is adjacent to the side length of 12 in the triangle. 15 over 12 can be reduced because both numbers have a common factor of 3. I'm going to go ahead and cross multiply. So my first cross product will get me 5x. My second cross product, I have to multiply 4 by the quantity 10 minus x. I'm going to distribute on the right-hand side. I'm going to add 4x to both sides, giving me 9x on the left. And I'm going to divide both sides by 9. So we could leave our answer as a fraction because 40 is not evenly divisible by 9. Or if you wanted to write it as a decimal, it is a repeating decimal, 4.4 repeating, if you want to write it in that form instead. All right, and one more problem for today's lesson. So what I'm interested in the last problem is finding the length of EF. So if we go into the diagram, I want to find the length of EF. So I just wrote X next to it. That's what I want to find in this last example. Now, we have a triangle at the bottom of this diagram where we have 2 parallel segments. So remember triangle proportionality theorem. This segment is splitting the 2 sides of the triangle proportionally. The problem with using that theorem right away is that I do not know what this first part of this side is. So I labeled BC's length with a Y. So my first goal in this problem is to figure out what y is equal to. And if we look at the top triangle, I notice that I have an angle bisector. AC is an angle bisector. So it is splitting this third side into two parts. And if I create a ratio with those two parts, this is going to be proportional to the two adjacent sides of the triangle. So y is adjacent to the side length of 18. 16, the second part, is adjacent to the side length of 24. 18 and 24 both have a common factor of 6 that I'm going to take out just to simplify that fraction. And I could figure out what y is by cross multiplying, or I could use equivalent fractions. 4 times what gets me to 16? That's 4. 4 times 4 gives me 16. So I have to multiply the top by that same factor. So 3 times 4 in y's position would have to be 12. So that was goal number 1, was to figure out that y equals 12. Now that I know that y is equal to 12, I can use triangle proportionality theorem. I know that this side, EC, or the segment, is parallel to the third side of the triangle. So it is splitting the two sides of the triangle into two parts. So it splits BD into part 1 and part 2, which I already happen to have labeled from the top triangle. And it splits this second side into two parts. Part 1 is 10, part 2 is x, and that's what I'm interested in finding. So I'm going to set up a proportion comparing the two parts of each side of the triangle. So the first side I'm going to take a look at is on like the left or the bottom of the picture. First part is 10, second part is x on the first side of this bottom triangle. If we look at the second side of this bottom triangle, the first part is y, or we just found y to be 12, and the second part is 16. So I want to figure out what x is. Again, I'm going to simplify this fraction because I noticed that 12 and 16 both have a common factor of 4 that I could take out. So if I do that, I'll get 3/4. I'm going to go ahead and cross multiply. So my first cross product, I get 3x, and my second cross product, I get 40. If I divide both sides by 3, I'll get that x equals 40/3, or if I wanted to write it in a decimal form, it could be written as a repeating decimal, 13.3 repeating. Either way would be okay.